How's it, guys? For those of you who don't know me, my name is Reece. For those of you who do know me, my name is still Reece. Today I'm going to talk about a very niche topic that I'm sure no one's heard of before. Not a lot of people speak about it. It's actually pretty new. Blockchain technology. Blockchain technology, I know actually I'm in a room full of IT people and it's like talking to a church about Jesus. I do understand that, but I'm going to try my best to maybe tell you something you don't know. And for those of you that do know more than me, I'm guessing please just suspend your disbelief. But okay, for those of you who've never heard the term blockchain before, for the one person here, that guy, I think, he's probably asking what the frick is blockchain, right? I'm going to explain that. And I'm going to do that with visualization. I found that trying to explain it with words without showing you a picture of a block doesn't really work. Okay, so there's three parts generally to a block in the blockchain. The first one being the data. Now, for something like cryptocurrency, that data would be transaction value, the sender and the receiver. But I mean, blockchain's much more flexible than that. And the data can be pretty much anything you want it to be. The next part is the hash. The hash is kind of like the unique identifier for that block, and it is determined by the content in the block, the data. So that'll be useful information later. And then the third part of it is the hash of the previous block. Now, what this does is it creates, I'm gonna give you one guess, a chain of blocks. That chain is essentially the first block, its hash, and then whatever the previous block's hash was. This together builds up a chain. Now, if you look at each block, the previous hash corresponds with the hash of the block before it. Now, two of the very, okay, I'm not there yet. Right, I need to go to my next slide. Thank you. Okay, now you're probably wondering, why do I care? Let me tell you why. There's two very powerful properties that the nature of blockchain provides. The first one being that it's distributed. This means there's no central authority that holds the information and you have to trust. Everyone has a copy and everyone can see it, everyone can access it, everyone can make changes if everyone agrees. And the other very important property is that it's immutable. Contrary to what it sounds like, it doesn't mean you can't put the sound off. It means it can't be changed. It can't be changed because, I'm going to go back to the slide. If you look at something like this, if I had to change the data in one of these blocks, right? Let's say I took block 2 and I changed the data inside it. The hash would change because, like I said, the hash is determined by what's inside the block. So if the hash changes, that means this hash is going to change. And when I look at this block here, the previous hash will point to the incorrect hash here. And okay, that means that that blockchain is invalid. But you could say something like, okay, Reece, we have computers that can calculate all these hashes very quickly. I could just update every single block after this one, and then it's valid again. No, because like I mentioned before, it's also decentralized. Everyone has a copy. So you could do that for your block and your blockchain. You compare that to someone else's and it's not the same. It's not the same as everyone else's. It's invalid. So these two properties are going to be brought up again and again by me, but please keep them in mind. Okay. Pretend you didn't see that. Okay, I'm going to go through some theoretical real-world applications. There are some applications in the early phases, but this really isn't in full-on production yet. So something like cars. When you look at cars, one of the major factors of a car's worth and what people are looking at when they want to buy it is its mileage, right? Mileage is measured by something called an odometer. And if you're a smart enough mechanic, it's actually pretty easy to just change that value. So you could have a car that's 10 years old, that's got 500,000 kilometers of mileage. You could make it 50 and you could sell that car. But something like a smart odometer, we would have that value frequently updated onto the blockchain by the car. And then if someone wanted to validate that the mileage that the car shows is what it has, it would be very easy to do. And something like car history, you'd like services, changes, parts, mileage. If you were to trust the person selling the car and the dealerships and all of that, you'd have to look through all that paperwork. If we keep it all on the blockchain, it's easily confirmed that it's what it is, and it's easily accessed by anyone that wants to. Another application would be the food industry. It's another thing that's very hard to control is keeping track of where food comes from, what it's been through, where it ends up. If you store this entire journey on the blockchain, for example, it would be easy to know where food came from, and if we needed to trace back contamination, theft, stuff like that, very easily. And one more that I'm going to mention, and I'm a bit skeptical of mentioning this because I'm sure there'll be a lot of questions about it, but voting. Okay, let's look at traditional voting. Paper is expensive, it's slow, and it's very susceptible to human error. And the word is cheating, I guess. Fraud. Online voting takes away some of those problems, but it's not safe. If the system you're using to vote isn't very, very, very secure, chances are someone's going to find a way to manipulate that and voting fraud again. But there is a way that we can stop all of this, and that's by casting votes and storing them on the blockchain. Now, there is a specific issue with this, and that's identity management. How do we verify that people who they are? And if we can verify that who they are, if everyone has access to the blockchain, people's personal information is very exposed. That's something to think about. That's not something I'm going to give you a solution to. Okay. So by now, if you're a skeptical person, you're probably wondering, Reece, you've just been saying put everything on the blockchain. That's lame. And it is. But I'm going to tell you another application that'll change that. Smart contracts. Right. Smart contracts are programs that run on the blockchain, and they can perform actions when certain conditions are met. This opens up another world of possibilities and allows for the automation of tasks and for more complex systems than just putting stuff on the blockchain. I'm going to go through one very specific one now, flash loans. This is lagging and I need to, yeah. Flash loans. Flash loans are a very powerful way of leveraging the blockchain and smart contracts. It's a way of borrowing money without collateral. What that means is, let's say I went to a bank, right? So forget about Bitcoin, forget about cryptocurrency for a second. Let's say I went to a bank and I said, please give me 500 million Rand, and I've got nothing to offer you as collateral for that. They would tell you to piss off. Bitcoin won't. So flash loans work by allowing you to borrow that money without collateral as long as you can pay it back within that exact same transaction. So you set that up with something like a smart contract, and you could set up a series of transactions after borrowing that money, and only if you can confirm that you'll still have enough money or enough of that currency that you're working in to pay it back afterwards will the transaction be approved. There's 3 specific uses of this that I want to go through. The first one is arbitrage. I don't think I need to go through arbitrage. I'm sure everyone already knows what that is, but just in case I will. Arbitrage is when you kind of leverage the different prices of things in different markets. So let's say in the real world example, I know that in South Africa, it's 10 Rand for a Bugatti, any specific one. Okay, it's 10 million Rand because people are laughing. I mean, it's just an example, but okay. And in Thailand, you can sell it for 12 million Rand. So you buy it in South Africa, you sell it in Thailand, you make 2 million Rand, right? Simple enough. Now, to do that with cryptocurrency, you could, but you'd need a lot of money to make a decent amount of money. And most people don't have millions and millions of rands stored up in cryptocurrency. What you could do is take out a flash loan, say, okay, I'm going to buy X amount of this coin, and in this transaction, I'm going to sell it for Y amount of this coin. I'm going to sell it again back. And by the end of that transaction, I'll have more Bitcoin or whatever the initial coin was than when I started. I'll give you back your money and I made profit. Another two examples are collateral swap and self-liquidation. I'm not going to go too deeply into them because it's quite finance and economics heavy, and I will not be able to explain it properly. But collateral swap, in essence, is let's say you had a coin, Bitcoin, for example, put up as collateral for a loan, right? And you wanted to exchange that for a different coin, but you don't have the liquid assets to buy back, well, to pay back that Bitcoin before you can swap out that collateral. You could do something like take out a loan for it, buy a different coin, swap it in for that collateral, get back your Bitcoin, sell that back for money, pay back the flash loan. I don't think making money is really going to be the goal with collateral swap, but it's good for if you want to change something like that. And then self-liquidation, well, that's liquidation. Liquidation is turning your assets that you have into money you can spend, right? How that works on the blockchain, feel free to do some research.